Okay, so in this video, we're going to look at what do we do if we want to add together two fractions that have different denominators. The most common mistake, this is wrong, don't do it, is kids will say, oh, 1 plus 2 is 3. And these aren't the same, so 2 plus 4 is 6. No, don't do that. This does not equal 3 6. Okay, Miss Cooper, we won't do that. What do we do? So this is where our understanding of equivalent fractions come in, which we practiced earlier. So I'm hoping some of you are looking at 2/4 and thinking, I know what equivalent fraction what is an equivalent fraction for 2/4 or 2/4. I can visualize it already and I have a guess what's going to happen. If you can't, think, well, I put up a little example in visual. So I hope some of you recognized, even just from looking at the picture, that 2/4 or 2/4, 2 being half of 4, is equal to 1/2. Notice you could just imagine erasing that line, the same amount's colored, or we could do like we learned previously using multiplication and division. 2 divided by 2 is 1, 4 divided by 2 is 2, 1/2. So suddenly we have a fraction that's equal to 2/4 that has the same denominator, the 2, the half, as we were trying to add, and this piece will fit nicely in there. So here you can see we've replaced 2/4, the picture, and the fraction with its equivalent, 2/4 equal to 1/2, the picture of 1/2 here. And now we can do the adding. 1/2 plus 1/2, the denominators being the same, equals 2/2, which we see there. So let's try this with a couple other questions. So in this example, they're asking us which of the following expressions equals 30/100ths. It seems simple, but when we look, we notice our denominator is not the same. It's tens and hundreds. This is nice because these are really easy multiples. I think we all know that 10 times 10 equals 100, so it'll be easy to turn these into their equivalent fractions that'll allow us to have a common denominator. Let's start with this first one. With this one, obviously, again, the denominators are not the same, so we can't just add them across. We're going to have to change. It might be easiest because there's 3 to both the top and the bottom here can be divided by 10, and 100 divided by 10 would take that down to 10. But a lot of kids don't like dividing, so we can multiply these instead. Miss Cooper, what are we multiplying them by? Remember, our goal is to make our denominators all the same. So how do we get from 10 to 100? Obviously, we're going to go times 10. Times 10. I'm going to do this over here as well. Oh, Miss Cooper, what we do to the bottom, we have to do to the top. Good remembering. Times 10 times 10. So the new fractions we have, these are done. 10 times 10 is 100. Sorry, that's not the best 100. 1 times 10 is 10. Same thing here, 10 times 10 is 100. 1 times 10 is 10. So now our new expression is 10/100ths plus 10/100ths plus the original 10/100ths. What does it equal? 10 plus 10 plus 10 does equal 30/100ths. So yes, this first one is correct. In this expression, both of these fractions are over 100, so definitely the easiest thing would just be to find the equivalent of 1/10 with a denominator of 100. So how do we get there? We are going to times 10 by 10. What we do to the bottom, we have to do the top. Now we have a new fraction. We can get rid of 1/10. 10 times 10 is 100. Sorry, this looks like 6's, but they're supposed to be zeros. 1 times 10 is 10. So our new expression is 10 over 100 plus 7 over 100 plus 13 over 100. We have the same denominator, so we can add right across. 10 plus 7, or I like this better. 7 plus 13 is 20, plus 10 is 30. So this one is also 30/100ths and is also correct. Last expression, same concept, different numbers. So here we have 2 that are over 100, so we want to make this one over 100 as well. So I'm going to go times 10 on the bottom, times 10 on the top, and 10 times 10 is 100. 1 times 10 is 10. My new expression, 10 over 100 plus 10 over 100 plus 10 over 100 equals, unsurprisingly, 10 plus 10 plus 10, 30 hundredths. So this one was a little sneaky. All 3 of them equal 30 hundredths. Last example we're going to look at together, same idea. Which of the following expressions equals 96 hundredths? To save me some writing though, we're going to sort of write right on here. Remember, we're looking to get 96 hundredths. Hard to write. There we go. So in this first one, let's look up here. 6 over 100 plus 5 over 10 plus 4 tenths. So sorry, 6 hundredths plus 5 tenths plus 4 tenths. I like multiplying better than dividing. So let's go ahead, especially because, yeah, we'd have to divide 100 by 10, but we can't divide 6 by 10. So we can multiply these guys much easier. Let's multiply bottom by 10, top by 10, bottom by 10, top by 10. So now we have this one, 40 over 100, or 40 hundredths. This one, sorry, it's a little bit squished in here, but 5 times 10, 50 hundredths. And adding together, 6 plus 50 is 56, plus 40 is 96. So 96 hundredths. So that one works. Next one, we have, let's multiply this guy by 10. I'm gonna go times 10 times 10. 8 times 10 is obviously 80. 10 times 10, 100. So now just adding 8 all over 100. 80, oops, plus 3 is 83, plus 13, 93, 96. There we go. Equals 96 over 100. So that one works as well. Looking at the third one. This is the only guy that I need to change. How do I get from 10 to 100? Obviously, times by 10. So let's do that. Times the bottom by 10, times the top by 10. And 10 times 10 is 100. 6 times 10 is 60. Adding up, 60 plus 14 is 74. Plus 20 is 94. Plus 2, 96. Yep, that one works. 96 over 100. Yep. And last one down the bottom here, just this guy in the middle I have to change. Timesing by 10, times by 10, times by 10. 2 times 10 is 20. 10 times 10 is 100. Adding up. 2 plus 20. Well, let's go this way actually. 74 plus 20 is 94. Plus 2 is 96. Equals 96 over 100. Again, all of them work. Sneaky example. Hope that makes sense. Good luck with this section.